So far, we have looked at three different data structures, and the three different data structures are, first of all, vectors. And vectors are created with the colon operator, or the C function, or SEQ, which is short for sequence, or REP for repeat. Second data structure is a matrix. So we define matrices, and those can be put together by the matrix function, or the R-bind, which stands for row bind, or C-bind, which stands for column bind functions. Third data structure is an array, and in the array you have multiple dimensions. You can have 3, 4, 5, or as many dimensions as you'd like, and numbers are stored in those arrays. But so far, the only type of data type that we have been looking at is numeric. And that is about to change, because in this chapter, we're going to allow complex numbers to be put into any one of those data structures. So here's one way to introduce this. I'm going to type I, and it will say I couldn't find an object I anywhere. That's because we haven't set I, and there isn't a built-in function named I. But watch what happens. When you put a 1 in front of I, now all of a sudden it recognizes it, and it is 0 plus 1I. So in terms of complex numbers, you probably remember these from high school somewhere. They have the form A plus BI, where A is the real portion and B is the imaginary portion. And in this case, A is equal to 0 and B is equal to 1. And there is a complex number. You can take this 1I, for example, and square it. And in this case, you get -1, as you would expect, because I squared is -1 from mathematics. So now I'm going to go ahead and define a complex number. I'll call it Z because that's commonly used in any complex variables course. And we will make this complex number 2 minus 3I. So again, if you look up here, you can see there is Z. It's been defined as 2 minus 3I. And if I type Z at the prompt, I will get a 2 minus 3I. What are some of the things you can do with a complex number? Well, one thing you can do is you can multiply it by a constant. I could take 5 times Z, and I'll get 10 minus 15I. The next thing you can do is you can multiply it by itself. So you can take 2 minus 3I and multiply that by 2 minus 3I, and you get -5 minus 12I. Well, if you can square it, that also means you can raise it to the 20th power. And there is a good 10 or 15 minutes worth of pencil and paper work taking our 2 minus 3I and raising it to the 20th power. Other thing you can do is you can take the reciprocal of a complex number, and there it is. Now, there is a second way of defining a complex number, and I'll show you how that goes. You could also say Z is equal to complex, and the real part here is 2, and the imaginary part is -3. That is exactly the same as what we did up here. In both cases, Z will turn out to be 2 minus 3I. How about two different complex numbers? Let me go ahead and clear this screen, and I'll show you what a couple of these might look like. If you have 1 plus 2I as your first complex number, and you want to add, for example, 3 minus 4I, those two will get added in the usual fashion that you would expect. That is, the real parts, 1 and 3, get added to give you 4, and the 2I minus the 4I gives you a -2I. Well, instead of adding them, as we did here, could also have subtracted them. And in this case, once again, the real parts get subtracted, 1 minus 3, and the imaginary parts, 2 minus a minus 4 is 2 plus 4, which is 6. In addition to addition and subtraction, you can also multiply two complex numbers. And of course, you've got to do the usual FOIL here. You have 1 times 3, but then you also have to take the two last portions. 2i multiplied by minus 4i gives you a negative 8i squared, but I squared is negative 1, so that's positive 8. 3 plus 8 gives you the 11 that you see right here. The same goes for the 2i. You have to take 1 minus 4i and add to it 6i, and that will give you a positive 2i. Finally, the last thing you might want to do in this case is you might want to come in here and divide the two of them. And you probably know, if you've worked with complex numbers quite a bit, the numerator and the denominators are both going to get multiplied by the complex conjugate of the denominator, which would be, in this case, 3 plus 4i. And that way you don't get any imaginary numbers down in the denominator. And in the end, this turns out to be negative 1/5 plus 2/5 I. There are a number of functions that can be applied to a complex number z, and here it is. The first is, you might ask, what is the mode of this thing? And it actually has a mode that is called complex. This is the first time you've seen something for a mode other than numeric, and this is complex. If you want to extract the real part of a complex number, it'll grab just the 2 there. If you want the imaginary part, there is a function im, and the I has to be capitalized and the m has to be lowercase, and it'll pick off the negative 3. There is another function called conj, which will get you the conjugate of z. So if we have 2 minus 3i for z, this will give you 2 plus 3i. Another function which will give you the modulus of z, and what that is the distance between the origin in the complex plane and the complex number itself, which in this case is 3.6. You can also ask for arg of z, and this will give you the angle that that complex number makes with the positive real axis. One last thing, it is possible for you to set these up not only as individual numbers, you can also set them up, for example, as a vector or a matrix. Let's just try a vector for starters. You could say z is complex, and the real portion might be a vector, and let's go with the vector 1 through 5. And then the complex, or I'm sorry, not complex, but rather the imaginary portion might be 6 through 10. And there it's set up, and you can now see over here z for the first time is a complex number, but it is in a vector form. So if I were at this point to type z and take a look and see what it looks like, there it is. It is 1 plus 6i, 2 plus 7i, 3 plus 8i, etc., all the way up to 5 plus 10i. You can also put these into a matrix if you care to. So for example, z is a matrix of complex numbers. The real values might go from, for example, 1 to 6, and the imaginaries might go from 6 back down to 1. Now we are in the matrix function, so we had better define some dimensions, and let's say this is a 3 by 2 matrix. And when you type z, you see there is in fact a 3 by 2 matrix, and the elements in that matrix our complex numbers. So that's it for complex numbers. They don't get used so much except in more scientific applications, but we at least now have two different things we can put into a vector or a matrix or an array. We can put in numeric values, or we can put in complex numbers.